Be continuing our transactions on our ledger, our blockchain that we're writing from scratch in Rust. We're going to make it real. We're making it real today. I want to make sure that we add a transaction. That's the one thing that we want to do here. We need to add a transaction into our database. It's not going to be like the full transaction. We might not even add a signature into it. I just want to be able to write a transaction into the database, and that's the plan right now. So let's get that going. So I have a query. We added the query here. And then I think we're fine with this. That's fine. That'll execute the query, but it doesn't. Let's see here. So here we go. Transaction. This is what I wanted. Here we go. So let's see. We don't want to bootstrap. We want to execute a query. This is what we're looking for here. That's what we're looking for. Okay. Then we need the con. So we got the connection here. I suppose we could do an and connection, right? Maybe. Is that what we want to do? All right. And then, so we've got we don't need ampersand that. We're building our own cryptocurrency. Let's just say that we're building our own cryptocurrency. We're doing it in Rust. It's quantum safe. It's got a quantum safe signature. And then we're using Lua for our smart. So let's jump back over to here. What I want to do is so we got an amount and then value. So it's 3. All right, I think that's plenty. Connection from to an amount. All right, there we go. Schema, perfect. Or we don't have to call it schema. We can call it, I guess, insert. Insert. Let's do that. Let's call it insert. Insert. Perfect. All right. So we execute the query. So we got the insert statement, and then we need to return probably. I don't know what it is. I don't know what it's going to be, but we could return. Maybe what we could do is we can return this. Maybe what we could do is return this. I think maybe this is a better idea. Instead of matching, maybe we can just return the execute query. What does this return? Just an okay on the connection. That I want to do. Hold on. This is Bootstrap. Okay, this is Bootstrap. So we're going to be doing a lot of Rust. The next few weeks, we're doing a lot of Rust because I think this cryptocurrency project is going to take a little while. I think it's going to take a few moments here. So here we go. All right, so I'm trying to decide on what I want to do here. So obviously I just don't want to return straight up. Okay, although I think it's fine because we've got the question mark here. So if it fails, however, we need. This is just to do it like an insert or a write operation. What if we want to do a read operation, right? So we can't just do this. We need to return this. I think it'd be better to return this. Let's see here. This is what I want to change. I'm going off script here. All right. So let's do underscore real quick. Connection result. We'll just say, okay. There we go. All right. So I want to make sure it still builds. Let's close this. Build. All right, we good? All right, run. Is it going to run? All right, runs without crashing. All right, we're good to go. All right, so what I want to do is instead of this, here, I want to change this. I want to just return. I want to return this. Just run connection execute. Here we go. No question marks, nothing, just straight like that. SQL result. And what it's going to do is it's going to, what are we making over there? All right, we're making blockchain. We're making our own cryptocurrency using Rust. And we have our smart contracts with Lua. Our smart contracts will be in Lua, as you can see up here so we got our code right here, Lua. You can also post in data, right? So if you're going to put an image or some sort of binary data, and we are also our signatures will be quantum safe. They're very big signatures, as you can see. They're a pretty big signature, 7,856 characters. That's a big signature. Do I really want that? Is that what I need here? Let's double check that that's the right size because that's pretty big. Here we go. All right, yep, that's it. Signature bytes. That's it. So we're using Sphinx. Sphinx is the quantum resistant cryptography that we're using, and it's going to be used for signing all of our transactions. The secret key, 64 bytes big, public key, easy, and the bit depth of the security, we're good to go. But that's a big signature. That's a really big signature. It's perfectly fine. I think we're good to go there. All right, so there we go in there. Is the ledger stored in SQLite? You got it, Kevin McAllister. We're doing SQLite, so we're using a nice ergonomic wrapper around SQLite for Rust called RustQLite. It's called RustQLite, you guys. Can the ledger be anything, even JSON? It totally could. So we could use, but I wanted to be able to index it. So you can totally make it JSON. So you'd make it like a JSON file that you would append all the ledgers. You'd you'd grab the last transaction to then use as signing material. So you chain it together because you want it to chain. So that will be a ledger. And then you can have a block signature JSON file. So you have two separate files, right? You have two separate files. And in fact, we do also need a block or what do you call it? We need to update our schema as well. Our schema also, we need another table. So this is transactions, and we need another table called something else. What do we call this other table? I guess blocks. Maybe we call it blocks. I'm going to comment it out for now, but it'll be called blocks. I think that's it. That's what we'll do. We also need to do this. This is a to-do item. We need to define blocks table. That's what we got to do. All right, here we go. So let's close that. I want to insert. So this is just an insert. So this is just a regular query. We're matching on the query. We're looking good here. And I think we could just return that. Is that possible? No, it seems like we gotta do something here. I guess there we go. Is that it? Is that all we gotta do is put a question mark? That's a good next step. Is that all we needed to do is add a question mark? Do you think that's it? Oh no, I was really hoping that's all we needed to do. Incompatible types. Okay. What kind of type does it want? It wants a result, an error. Okay. So it expected this right here. So let's grab this. And what we can do is this will be the output. Although I want to double check. Oh, I think we're good there. So instead of that, so we'll go, paste. There we go. Result. I think what we can do is we don't need SQLite result anymore because we're in a new file now. So we're just going to call it result like that. There we go. We're just going to call it result. So it'll be an, right. I wonder the client side works. Okay. You wonder how the client side works? When they run the client side code, will it copy the ledger from your server? Yeah, you got it. It's got to synchronize. I'm realizing not so sure about how crypto works. You're right. You figured it out. So it needs to get a history of all the previous records, or at least the most recent records. So that way, if you open up, say you want to transact, you want to send money to someone, you need to get the most recent, or within the last 60 seconds, or the most, at least roughly the most recent transaction. So that way you have something to chain off of, because it's going to be used in the signature. It'll be used in the signature. And then another server, or the fleet of servers that are running the network, right? The blockchain network will validate that transaction to make sure that it matches. And it will also validate through a chain. I think that's the plan. I think that's what we're going to do. Or is it like peer-to-peer and there's no central server? That's the idea. We want to make sure that there's no centralization. You would want a central server, right? In case no one's online. So that's how we have to start. You're right, Kevin McAllister. We need to have a seed server. We need to have a seed server at least for the beginning, at least for the early days. And then eventually the network will get big enough. We don't have to have the seed server online anymore. It would. So I think so that'll be an error. But I want to, instead of doing that, I want to say, error. There we go. Error. Perfect. There. So it keeps things clean and simple. Bootstrap the database. Yep. Bootstrap the database. Schema up. Sounds good to me. That will also give us the connection. We're executing the query. We're happy there. Now we need to do an insert statement, which we cannot do. We can do this. This will work. You know what? Why don't we just do that? So let's do transactions. Let's do ledger, transactions. There we go. All right. I think this is fine. This is like the beginning. We don't want, we do want the con. Here we go. Here's the con. But I don't need to say ampersand because it's already expecting. Oh, actually, I do need to say ampersand. All right, let's see if it works. Did we build it? All right, we built it. Run. Cargo run. All right. Oh, error loading database schema table transactions. The table transactions has no column named account. Oh, to account. Oh, it's working. The code we write is working. Isn't that amazing? Now all we have to do is change our schema, or sorry, not a schema, our SQL. So let's get our query working. We got from address, to address, and amount. So to account is called address. That's why. Watch this. FA. There we go. FA. No. FA. There we go. Boom. Boom. Address. Done. Did we fix it? Wait. Oh, you got to rebuild it. Cargo. Here, I've got an idea. Cargo build and cargo run. So that way we're always up to speed. There error loading database schema, not null constraint field. Oh, we got a not null version. All right. So It's working, you guys. The system we built is working. It's so great. Oh, I'm so happy. This is very satisfying. All right, let's make this prettier. Let's make it prettier and easy to read. Can we do does it support multi-line? Let's find out. Let's try this really quick. Yes, it does. Okay, perfect. So this is what we'll do. Insert into, go like this, right? We got our values like that. I think that looks good. All right. Actually, you know what? We can bring this back up on the top line. Add AI also. We should add AI. We should update the stream title to also say we're going to add an AI. So what I want to do, all right, let's do it. All right, let's add AI. Let's do it. All right. We're changing things up. We're going to add AI right now. All right, here we go. Plus AI. Let me update the stream title really quick. Let me update the stream title. Plus AI. AI, Rust blockchain. There we go. All right, let's just put the word AI, Rust blockchain. Update all. All right. We updated it. Now it's going to say, yeah, and we're actually going to, so let's see. I don't know. What's the best AI? So what's the best AI framework for Rust? Best AI framework for Rust. Maybe something like libtorch related. Is it libtorch related? I don't know. With Rust, the most recommended and actively developed frameworks are Burn, SmartCore, and Linfa. I've heard of Burn. I remember Burn. So there's no information available regarding the specific framework called libtorch. Because I typed it wrong. LibRoch. It's called libtorch, not LibRoch. Jump back to our code. So we've got one. This is what we got to do. This is the most important thing. I want to be able to insert into our ledger. I want to insert into a ledger. So let's grab all these things here. We'll grab them all here, and then we'll put them over here. All right. We'll indent. Let's see, 2. There we go. And then we'll just go right. So here I've got the idea. F comma, there we go. X, there we go. Yep. So we're gonna make this happen. All right. So ID, and then prior ID, signature. We're gonna get all of these things here because we have to, because they're all not null. And you know what? We'll just grab everything. The only thing that's not null is the code. The only thing that's not null in here is the code and the data, because you don't need data or code in order to commit a transaction. But we'll put them in anyway. We'll put them in there anyway. I think that's a good idea. Smart contract. All right, data. We'll grab data, and then we'll also do our Lua smart contract. There we go. Now what we need to do is we need to make sure that we populate all these things. So let's go ahead and populate them. Well, we'll populate them. We'll do placeholders. I think we'll do some placeholders. I think it's a good idea. We'll do some placeholders. All right, here we go. All right, so how many of these do we need? So version 1, we'll just copy and paste. We'll just copy and paste it again. So that way we make sure we get them all. We need to make sure to get them all. All right, so we grab version. Version's there. Difficulty. What is that for? What did we... Oh, because that specifies how many S's. So that's just going to be an integer. So that'll be fine. We'll just say 1. We'll say 1 difficulty for now. We'll do 1 difficulty. We'll play it up. Nonce, we'll just say 1 because we're not going to bother with it. We're not going to bother with it for now. ID, we can do a string. We'll do a string of, we'll just do placeholder ID. We'll do an ID there. What else do we need? What else? So we got difficulty, nonce, priority, and we need previous signature. So we'll do that. We'll add those in here. All right, we're making progress. I like this. So let's go. Oh wait, I've got an idea. Here we go. I like this. There we go. We'll populate this. So timestamp. What is this? What is our timestamp? It is it's just an integer. Okay, that's perfectly fine. So we can do, it's going to be a Unix timestamp. Let's do Unix timestamp. So then we got our from and to address, perfect, which will be these guys here. From address to address, done, and then amount, we got it. And the note will be note, and then data. Let's say data, and then code. There we go. All right. I think we got it. Is that it? Is that everything? No. This is going to be an integer, so we're good there. Let's just pop that over here. This is difficulty. No, wait, we already, difficulty's up here. What was that string? We got version, difficulty, nonce. Is nonce going to be, wait, what is nonce? Nonce is an integer. I don't know if I want that to be an integer. I don't know if I want that to be an integer. Actually, it's probably fine. We could probably do, because I'd rather it be a string. Oh, nice. That's the one that we're using for our signatures on our ledger. Because it's a chain of signatures, right? Because every transaction needs to have including a signature from the previous signature, so that way you can chain it all together. So let's see if we can get Let's check these AIs out really quick. Let's check out SmartCore and Linfa. Let's check it out. States, where does Linfa stand right now? Currently, Linfa provides sub-packages with the following algorithms. Okay, so we've got, okay, so this looks like standard machine learning. Like, so we got some regularization in kernel, maps feature. I want hardware acceleration is what I want. Support. Okay, so this isn't deep learning. I want full-on deep learning. This is standard classical machine learning, right? Machine learning. Yep, it is. I told you, it's machine learning. I want a deep learning framework. So let's check out Burn. Rust Burn. Let's check this out. All right. Is this a deep learning? Burn is a next generation tensor library for deep learning. There we go. All right. This is actually probably what we want. Burn is both a tensor library and deep learning framework for optimized for numerical computing, model inference, and model training. Burn leverages Rust to perform optimizations normally only available in static graph frameworks, offering optimal speed without impacting flexibility, you guys. What are we doing? Can you explain? Yes, exactly. We're building our own blockchain from scratch, and we're adding AI to it. Yeah, so we're going to add Burn. Let's add Burn. So here, this is our LinkedIn Live right now. All right, so let's pop out of that really quick. Let's go over here. All right, bring that over here. Now, let's add Burn. Let's add Burn over here. Let's do it. All right, so what do we need to do? Let's look here. How do we get it running? All right, so a recursion limit. There's a recursion limit? The idea is that you offload some tasks into a application-specific processor or coprocessor, which is a GPU, right? Like a GPU that can do specialized processing in concurrent processing. And so that's what we're building. We want to build with this. So that's the idea. So I don't know if I want Burn or not. I'm not sure. What we could do, we can. It says it's for Rust though. Maybe we will. Maybe we can just do it. We'll see. Let's see. All right. Let's see. There's a get started here. Burn book documentation, please. I want the documentation. Hey, I want an easier documentation. Is there something better? Training, backends, quantization. Let's check out backends. It'll be there. We still need to integrate that anti-51% measure. We do, Torba. You can't forget it. It's listed here in our to-do items, right? Right here. We've got an approach. We got to implement it as well. So we've got work to do. Query reader. Hey, I want to add in a query reader. A reader. SAQ 3000, thank you for saying hello. Good to see ya. All right, here we go. Let's jump in. So I want to add a new function, and this new function will be just a query. So this is like read. So instead of execute query, I want to call this just called execute, so we don't confuse the two. I don't want to confuse the two. There we go. So it's just going to be called execute. Just execute. There we go. And then we're going to have a query function, right? A query. I need to read the docs. We got to read the docs, you guys. /mer. There we go. Actually, what we should do is comment this out really quick, just in case. I want to make sure we can still build. See if we can build. Is it going to run? All right, so we still got it. We're good to go. All right, last thing we're going to do here is I want to use the connection and grit the query. All right, so this is going to be a query. So it's a read. It's a read operation. We're doing a read operation. All right, so I need to just do this. Let's do this for now. Let's just print it. Found transaction. Perfect. Let's found transaction, and we'll just return nothing. We'll like do this. Check this out. All right, let's see if this works. Let's see if this works here. It kind of did. We only got warnings. Really? We only got warnings? Isn't that neat? Look at that. We only got obviously we should take care of the warnings to make sure their query is never used, obviously. Query. Oh, wait. We're calling. Okay. So we'll call this maybe call this statement. We'll call this STM statement. There we go. We'll call that statement like that. Burp. There we go. Statement. Mute statement. Okay. Let's see if that works better. Let's see if that's a smidgen better. It is. We did. It's a smidgen better. All right. So we don't have any other collisions now. We just have dead code. We only have dead code. All right. We only have dead code, you guys. All right. This is getting good. We're almost there. We're almost there. So this is the last thing that we're going to do today. What's happening? What is happening? Kevin McAllister, we're writing a query statement for our ledger so that way we can read out the transactions that we wrote. We can read the transactions that we wrote. So I'm going to open up our main file so that way we can now, after we did the transaction, right? We did our own transaction. Now we're going to do a ledger. We should actually, you know what? We'll just do a query. We'll just do a query. Select star from transactions. Limit. We'll do limit 1. So we don't do, because there's more than one transaction now at this point. And then we want to, we're just going to run it. We'll just run it. Well, I think that's a good plan for now. I know we're almost there, you guys. We're almost there. Cargo build run. Okay, so it did it. It did it, but the problem is the query, is it actually loading? Select star from transactions, limit 1. Let's try limit 2. Await unwrap. Okay, that's fine. That's fine. To do unwrap errors. Oh yeah, we got to unwrap the errors. Okay. So we probably should be doing that. I think that's something that we should be doing. Is that select star from transaction limit 2? I think that's perfectly fine. So this is the last thing we got to do. All we got to do is get we need to get our print statement going. So let's see. RustQLite, RustQLite. There we go. Docs. That's what I'm looking for. All right. I just want to. It seems like it really wants me to do like this. What I suppose we could do this, right? We could get. I think we could do this and just let's see if we could print that. Let's see if we can print that. Let's see if that's a different thing. Print this. All right. Let's see. Let's see if that works. This won't be the full transaction. This will be something else. But let's see if it works. Required by this. Wait. Okay. We've got some hefty error. Oh, get 0. The trait from SQL is not implemented. Uh-oh. All right. So then how do we, I guess what we're going to have to do is we'll just have to follow this pattern. We're just going to need to follow this pattern here. That means that we need to define a struct, right? We need to define a struct. So like this, it's a struct like this. Set. So we'll call it a transaction. Yep. Wait. Set no paste. Transaction. There we go. Excellent. Any thoughts on time travel? So it will be, what we'll do is, what is our schema? What is this here? Where is it at? Here we go. So it'll be this. We'll just copy and paste this here. There we go. All right, there we go. Perfect. All right, let's see here. So we can pull this in. Version. All right, so it'll be an ID 32. I'm pretty sure this is an ID 32. There we go. Difficulty. Wait, we need to open up our schema again so we can get that going. Schema. There we go. So what is our data types here? What are our data types? All right, so we got integer. All right, so ID. Oh, there's no ID. There's just version. Let's just pop this up here. All right, so version, difficulty, the same thing. We got the same thing. We need to type this. It's going to take a little while. It's going to take a few moments. Same thing again. And then ID is a var. It's a varchar. So how do we do that? Is it going to be a string? I think so. Let's see. This is a signature, which is also a string, and a timestamp, which is an I64. Yep. From another string. We got another string. We've got another string, and this is we'll do a float. Yep. All right. We almost got it. Let's see here. That's lots of data. Oh. Yep. All right. Works for me. Hold on. So, okay. One second. Hold on. Oh, look at that. All right. So we can have comments in there. That's pretty neat. And then code. Data is a string and code is a string. There we go. I think that's fine. Although this might be a problem right here. That might be a problem. But I kind of wanted this to get going. So what I'll do here is here. What I want to do is we'll just comment some of the stuff out for now. We'll comment some of the stuff out and we'll just do version. That's all I want to do. We'll just do version. There we go. Also, I could do this, right? There we go. Just grab the version. So this is transaction. Close this. Coming back over here. Here we go. All right. So execute query. All right. Smear statement. Let's pop over here. Let's recopy this. I think what we're going to do is we're just going to do this here. We're just going to grab that. And then we're just going to paste. And then we're going to redo this. We're going to redo. Oh, wait, no, I want that. We're going to read this. There we go. Set no paste. Oh, wait, no. Set no paste. Perfect. All right, there we go. So we got our statement. And then we got our the iter. We'll just call it the iter. Iter. Yep, here we go. Bopped it right there. Set our iter. Yes. Yes, most of coding is logic. And the linking of that understanding to the appropriate syntax used by the computer language. Yes, you're right. You're totally right, Torva. Can you fix a bug in it? What we could do is we can ask the AI to help us with this one really quick. Just to give us a little bit of hint here. Just a smidgen of a hint. So we'll grab that really quick. And then we'll open up we can't. Let's do this real quick. Update. We'll update it. We'll grab this one real quick. Let's see. We'll open up Codex really quick. Let's see if it can give us some help. See if it can help us out. And what's the file called? I think it's called Ledger. Okay. At src/ledger. Here we go. We'll see if it works out. We'll see if it comes up with anything interesting here. Actually, you know what? It's totally fine if it edits the file. I don't care. Is this it? Okay, so it wants... Oh, that's it? Just the match? Is that all it is? It's just to do a match? That's the whole time? That was it? That's amazing. I can't believe it. I could have done that. I could have done that the whole time. That's crazy. All right, here we go. So let's read where we made the mistake and where it's better now. Okay, so it was... Let's see if it runs. Are you guys ready? Do you think it'll run? Cargo build looks fine. Field in this struct. Warning, never used. That's fine. I'm fine with that. And then and run. Wait, cargo run. Here we go. We did it. We did it. We did it, you guys. All right, we did it. We succeeded. We got the transaction right here. Check it out. I know we're only printing that we've succeeded today at adding a transaction to our ledger, and we actually printed out some of the transactions on the AI stuff. But we added AI to our blockchain. We did. We added AI. It works. We're good. Maybe more blockchain, but maybe more AI. Maybe we'll switch up to AI for a little bit. Maybe do an AI stream tomorrow. Can I contribute to Steven's Nakamoto coin? You can't give him McAllister. You absolutely can. Oh, wait. Let's commit this. Let's push this in. So get status, get add. So we added AI, get status again real quick. Get commit-am. Added AI. We added AI. There we go. AI burn library. And then we also added transaction. Wait, transactions. There we go. We did it. We did it. Push main. Done. Boom. Off to the races.